We're going to do two problems in this next video. The first one wants us to use the product rule to differentiate the following. So again, be careful with directions because you could actually multiply out h of, that says h of t, and that's not right, that's h of x. You could actually multiply h of x out and then just use the power rule. It would be really fast. So for example, let's do it real quick. If I multiplied 2x times x squared is 2x cubed, 2x times 5x is plus 10x squared, 2x times negative 3 is minus 6x, and then 9 times x squared is minus 9x squared, negative 9 times 5x is minus 45x, and then negative 9 times negative 3 is plus 27. If we combine our like terms, we have 2x cubed, we have a 10x squared minus 9x squared minus 45x, so that's going to be minus 44x. I believe I did that correctly. Oh no, one of those was an x term, not an x squared. Hold on, let's try again. That's actually a plus x squared. Then we have a minus 51x plus 27. So we could actually rewrite h of x like that. And then if we took the derivative, we'd just use the power rule. So I'd get 6x squared plus 2x minus 51 as my final answer. However, we're not allowed to do that in this problem because it specifically says to use the product rule. Okay. However, I want you to get comfortable with ways that you can take derivatives quickly because that will help as we get into chapters 5, 6, and 7. So for now, let's erase this. You can kind of keep this in mind as a check to make sure that you have done the product rule correctly. All right. So again, the product rule you should have memorized. Now, if you're going on to Calc 2, you will definitely need to have the product rule memorized. But if this is your last math class, maybe you don't memorize it because you're going to be given a note card on all of your exams, and that's fine. So what does the product rule say? The product rule says when you take the derivative, you're going to, let's take the derivative, you're going to write down your first function. Just leave it alone. So I have 2x minus 9. Multiply by the derivative of the second factor. So the derivative of x squared plus 5x minus 3 is 2x plus 5. Then you're going to add the derivative of your first function, the derivative of 2x minus 9 is 2, times your second function, x squared plus 5x minus 3. So we're basically done taking the product rule, but we do need to simplify by distributing and combining like terms. So we have 2x times 2x, which is 4x squared, 2x times 5, which is plus 10x, negative 9 times 2x, which is minus 18x, and negative 9 times 5, which is minus 45. Then on the other side, we're multiplying the 2 out. So I have plus 2x squared plus 10x minus 6. So let's see what we get. 4x squared plus 2x squared is 6x squared. 10x minus 18x plus 10x is going to be minus 2x, I believe. And then we're going to have minus 51. Oops, that was a plus, sorry. Plus 2x, minus 51. All right, so that's how we can do that using the product rule. Let's look at question 7 now. This is very different. This one says, find the equation of the tangent line to the function y equals 1/3 x minus 4 times the square root of x at x equals 1. Now this problem can look really, really intimidating when you first read it. But they want us to find the equation of a tangent line. So let's remind ourselves what they really want us to do. We know that the equation of a line can be found by y minus y1 is equal to m times x minus x1. So what we really need to find this line, or find any line for that matter, is we need a point and we need a slope. Now the point we can get rather quickly using our information that x is equal to 1. So if x is equal to 1, what happens if I plug 1 into my original equation? I'll have 1/3 times 1 minus 4 times the square root of 1, which is 1/3 minus 4, and that's going to give me negative 11/12. Finding a common denominator, 1/3 minus 4 is 1/3 minus 12/3, which will give us a negative 11/12. Wait a minute, that doesn't make sense. Negative 11/3. Sorry. Okay, there, that looks better. The next thing we need is we need a slope. Now the slope is important because if you're looking at a tangent line, and tangent lines only, the slope comes from the derivative. We've learned this through multiple exercises that we've done. So technically, if we can find the derivative of y and then plug in our x equals 1 value into that derivative, we will have our slope. So once you have the point and the slope, you're ready to find your line. And we already have our point, we just found that. So let's go ahead and find our slope. First, let's rewrite our original function. 1/3 x minus 4 times x to the 1/2. We'll change that square root to an x to a power. So our derivative is going to be 1/3 minus 2x to the negative 1/2. All right, using the power rule. What is that evaluated at 1? Well, y prime of 1 is going to be 1/3 minus 2 times 1 to the negative 1/2. Well, 1 to any power, even if that power is negative, 1 to any power is just 1. So that's really 1/3 minus 2. And 1/3 minus 2 is 1/3 minus 6/3. So we're going to get a negative 5/3. So we have our point, we have our slope, we know the equation for a line. So we're going to get y minus a negative 11/3 is equal to our slope of negative 5/3 times x minus 1. Y plus 11/3 is then going to be equal to negative 5/3 x, sorry that got a little jumbled, negative 5/3 x plus 5/3 when we distribute. And now we're going to subtract 11/3 from both sides. So we have y is equal to negative 5/3 x minus, let's see, 6/3. Oh, how exciting. That means we can simplify. Y is equal to negative 5/3 x minus 2 would be the equation of our tangent line. Now I want to remind you, fractions will occur at times in this class. You've already had them a couple of times on homework. If you're nervous with fractions, just go slow and remember to show all of your work, because if you have an error in the arithmetic, that's not going to be as drastic as an error in the new calculus of all of this. So if you subtracted 11/3 from both sides and you got an incorrect value, you're still looking at probably 9 points out of 10, as long as the rest of it was done correctly. So be aware, we will be working with fractions, but if you go slow, you should have it handled.